Hello, my name is Michael Reeves. I'm the Communications Chair for the ISC2 Boulder Chapter, and I'm going to talk to you today about getting started in IT security. Today we're going to cover three major topics. The first is understanding what jobs are out there currently in the market. Second is to understand what kind of skills are needed to qualify for those positions or to increase your chances as a candidate. And the last topic is the forever question of how to get experience without a job and how to get a job without experience. And hopefully, after watching this, you'll have some new tools in your toolbox to be able to distinguish yourself in the market and to land that first job in IT security. So what kind of jobs are out there? What I did in preparing for this presentation is I pulled up LinkedIn and I set up a job search for the Boulder area. I think 50 or 100 miles from Boulder. I specifically selected the entry-level positions and internships in order to see what kinds of positions actually are there and available for new individuals to the field. And this gave me some insight on not only the diversity of the different positions, but it also assured that there are positions that are available, and companies are hiring, are looking for people getting started, which has historically been somewhat of a challenge. So the first position, kind of positions that I found were in regard to tech support or help desk. Now, what these positions do is they generally answer phone calls, emails, things of that nature in order to generate tickets. And it's the first line in IT where customers typically have an issue, and that issue then needs to get routed to the appropriate teams. And that's the role of either the customer support or the help desk personnel. The next level where they kind of route those tickets are the desktop support and the technical support teams. And I did see positions that fit under those categories, those distinctions. The main difference between like a help desk versus like a desktop support or a technical support is that they typically are troubleshooting workstations or a specific type of product, and that's really the distinction between those two categories. Is desktop support is really about supporting workstations, and technical support is keeping some kind of product or service capability up and running and resolving tickets related to that. I also found systems analysts and cloud developer. Now, the difference between the two, those are very similar in concept, but also very different in application. So, a system analyst is somebody who maintains those same systems. So, like we were talking about with technical support, you're typically supporting a product or a service or something of that nature. The systems analyst is the people that just maintain it above and beyond responding to tickets like the technical support does. Those are the individuals that make sure backups are running and checks the health and status of those services and perform updates and patching, that sort of thing. Cloud developer is very similar, but it's cloud centric. So this is specifically about supporting products and services that live in the cloud. Think more along the lines of like a software as a service type of thing, which a lot of companies have moved towards. Another area that I saw some positions was data analyst and AI trainer. I did group these together because they're both intrinsically related to working with data. I was very surprised to see AI trainer on this list. So that does go to show how much AI has really impacted and influenced the way in which companies are supporting and driving their IT services, and the demand for AI in the market. Now, the difference between the two is that data analysts are the people that are going to be managing and maintaining the data, the databases, things of that nature within a system. An AI trainer uses data in order to improve the AI model itself. So where a data analyst would be more about improving and maintaining the databases and the metadata within the databases and the data itself, AI trainer would be taking data and feeding that into an AI in order to give it more context, give it updated information that it can pull on, that sort of thing. And then I also found the junior systems engineer. I was really surprised to find this because this tends to be more of a middle position, one that's not normally associated with entry level. But a systems engineer is a position that really designs or develops systems. It's understanding processes or interconnected systems and how they work together. So a junior systems engineer would be designing and developing systems like that. That being said, being junior, they would be under the supervision of a more seasoned engineer. Now, what is the commonality that we're seeing here? Not a single one of these is specifically talking or focused on security. And part of my search was specifically saying cybersecurity. So, why is that? The reality is, none of these are particular cybersecurity focused for a few reasons. One of which is that cybersecurity is the application of security ideas in an operational environment. You first need to understand how operations work, and all of these positions are those entry level positions, getting your foot in the door, understanding the role of help desk, understanding the expectations of the first level support, understanding the data that is used in a system, and how that relates back to business values and things of that nature. So these, while aren't directly related to cybersecurity, are the foundations of IT that is cybersecurity expert, professional would need in their repertoire. Which takes us directly to what kind of skills would you need for these same positions. So we're going to go through those positions again, one at a time, and kind of analyze what skills are needed or requested by the company that's trying to fill it. So for customer support and help desk, the kinds of skills that they're looking for is people skills and general IT knowledge. The reason for that is because most of the time you're directly working with people that are submitting tickets, typically people who are not happy that are submitting tickets. So being able to communicate gracefully with them, gather the information that's needed, potentially de-escalate, having the appropriate IT knowledge to know what team should that ticket go to. What technology is that issue related to, and what team is responsible, so you can assign the right ticket is also general knowledge that you would need to know in that position. Which takes us directly to desktop support and technical support, since that's where the tickets are going to be going. As I'd mentioned previously, desktop support is focused on operating systems. So you would have to have familiarity with those operating systems. You would have to understand basic troubleshooting for those operating systems, configurations that need to be changed that could resolve the issue, that sort of thing. Technical support, as I mentioned before, is typically associated to specific product or service. So there's a little bit more specialized IT knowledge, which is focused on that specific product and or service, but that still directly correlates back to having troubleshooting knowledge and skills. For system analysts and cloud developer, you would have to have knowledge on how to maintain a system. You would have to, for a cloud developer, you would have to have familiarity with cloud products, preferably in the cloud environment that they're operating. If that company has a SaaS product that's in AWS, for instance, familiarity with AWS's product suites, familiarity with how that product works and how communication is possible through it. What sort of configurations need to be set up to ensure that the traffic is allowed to fly through the cloud. Understanding ideas like having your cloud in different locations so that if one location goes down and bring it back up. That sort of knowledge, it's what is kind of expected for those positions, or needed to help distinguish yourself in a position like that. You would need to have familiarity with configuration files, infrastructures, code, all of that sort of thing for the cloud developer. System analysts would, of course, need to have similar types of knowledge, understanding configuration files and dependencies of software and things of that nature. For data analysts and IA trainer, this is the main reason why I grouped them together, is because they're both associated with understanding the data types and the business value of that data. With AI trainer, then you also have the data training models themselves that you would have to have familiarity with. But this intrinsically goes down to knowing what the data is, as well as why it's important to the company, because that very much influences the way in which that data is managed and protected. For junior systems engineer, this is where you can demonstrate that you can build a system or develop processes, understand what inputs are needed, what outputs should be expected, what that chain of the process is in order to go from input to output, understand what components provide those capabilities. That's what kind of entails a system engineer. So with all of these skills, with all this knowledge that you would be expected to know, where would you acquire such? Like, why are these skills associated with non-cybersecurity positions that don't really have an emphasis in their duty titles or activities that have a heavy emphasis on cybersecurity? I personally think that this correlates back to my time when I was in the military, and every year we had to do firefighting training. Every single year, part of the training was to drill in that the three components in order to make a fire are oxygen, heat, and fuel. And in order to put out that fire, all you need to do is remove any one of those three components. You drench it with water if it's the right type of fire to do that with. And you are suffocating the oxygen. You're also taking away the heat. You know, other firefighting methods such as halon takes out the oxygen and it stifles the fire as a result. But the cornerstone is understanding that how you have to what is needed to create a fire is the critical piece of information to know how to fight that fire. Cybersecurity is the exact same way. You cannot possibly know how to secure something that you don't know how to configure. You cannot implement protections. You cannot put mitigations in place if you don't know where the attack vectors are, if you don't know how the attacks and the exploits would be executed. To do so, to attempt to implement cybersecurity without really understanding the system, would be the equivalent of putting up random pieces of fencing in your backyard that, unless it's a complete fence, you're not protecting anything. Anybody that can see what you're doing can simply go around it. And that is why understanding what the attacks are, what the attack vectors are, what the methodologies are, what the associated configurations and the exploits and so on and so forth is pivotal in understanding how you best set up defensive measures. And cybersecurity is as broad as the IT field itself. One of the challenges is it's difficult to know everything about everything. In fact, I would dare say it's impossible to know everything about everything. I remember when I was first starting in my career path, a coworker of mine who was more seasoned than me was impressed with my my development over the years that I worked with him, and he asked me what I planned on specializing in. I gave him a very candid response, and his retort to that was not what I expected. I told him that I wanted to learn it all. I wanted to do everything, and he frankly told me that that's impossible. You have to choose a specialization. You have to go down a path that makes you stand out, makes you unique, makes you different than all of your competitors. And while I understand where he was coming from, what I did not realize at the time is what I was really saying is I wanted to go in the field of cybersecurity, because you have to understand how everything really works in order to defend it. So you have to, in a way, be a jack of all trades. So I encourage you to learn as much as you can, because you will see how all the dots connect the more that you learn. But while doing that, you have to find what you love. And I think that's what my coworker was trying to get at. If you find the piece that you are really interested and really passionate about, you will naturally want to learn more about it. You will naturally become better and more specialized in that area. And for me, that it end up being networking and just in general security. So I encourage you, do what you can, but find what you love and pursue that. Because no one can teach you passion. And that's what this really comes down to. Going in this field that is so diverse, you have to have passion for it. Otherwise, you will hit roadblocks. You will be your own roadblocks. You will have stumbling points. You will get discouraged and not want to keep moving forward. And in order to combat that, you have to dedicate some free time to always learning something new. Technology is always changing. Uh, I remember when I was still in college, there was a lot of talk about AI way back then. And I had a professor that swore up and down we would never see AI as really as he defined it, which we haven't because he was really defining general AI, like data from Star Trek. But the big rage at the time was machine learning um, and expert systems, which AI is all built off of that. I also remember at that time the cornerstone to any solid security practice was firewalls, which we still have today. But the firewalls that we had 20, 30 years ago and the firewalls that we have today are substantially and significantly different. So you always have to be learning new things in order to stay up with the latest developments and trends. I know that right now a very hot topic when talking in the cloud environment is identity management and ensuring that authentication is secure in a cloud-centric world, especially with API communications that are happening between systems and single sign-on and so on and so forth. So always find something new to learn because you don't know what you don't know until you know it. And so if you allow yourself to be stagnant, you will allow yourself to become outdated. And part of that is always being willing to practice. A common misconception is practice makes perfect. And you hear it all the time. But in reality, practice doesn't make perfect. Practice makes permanent. I remember one time when I left for a deployment, I went from being a Linux firewall administrator to being basically a help desk person, and I managed Windows systems. Completely different environment, completely different experience. And months later, when I returned back to the States, one of my coworkers had asked me how to do something on the firewall, which I can't recall what it was, but it was something that when he asked me, I was like, I don't think you can do that on Linux. And he's like, of course you can. You did it. I just don't remember how you did it. And what I had done is I chained together certain commands, pipe them, and to get the output that and certain types of information that I was looking for. But I not only forgotten that I'd done it, not only had I forgotten how to do that, but I'd completely forgotten that I'd even done that. And that is why practicing is so paramount. And it's one of those things that, just like learning a musical instrument, for instance, the more that you do it, the more that it seeps in, it becomes second nature. And my experience administering Linux systems for years has resulted in me remembering things that I've done hundreds or thousands of times but it's just like riding a bike, and that's why practice makes permanent. If you do a tutorial once and then you move on to something else, you're not likely to retain how that to the level of being able to reproduce it. You might remember the concepts behind it and everything, but you probably will not be able to reproduce it. So having some means to practice the skills and knowledge that you want to be able to retain is paramount. And this also goes back to showing your work. When you have a Bitbucket or a GitLab or something like that that you can publish your hard work on to show how you've solved a problem or created a solution, um, or just did something for fun, that is a testament to your knowledge and skills and capabilities. It's something that you can reference on your resume that anybody can look at, and it doesn't have to be perfect. It doesn't. Um, but it is something that is traceable back to you, that you can say, this is me. This is what I'm capable of doing. This is my caliber. This is my quality. And it's something that any company that you've submitted an application for can go look at themselves. Which, whenever you're working on a project, on a little side project or little personal solution that you're putting on GitLab or anything of that nature, make sure that you're iterating and diversifying. It is okay to start with something incredibly simple. In fact, it's preferred. For example, when I first started hosting my own website, my own personal website, it was a basic flat HTML Apache server. It served pages, people downloaded the HTML, and that was basically it. Um, and then I added to it. I changed it from HTML to PHP to allow it to have dynamic content, to allow it so that I can have the header and the footer as separate files, which I know never change, and then I can make the body something that changes depending on which of the pages that you're in. It's less code for me to manage. And then I thought about the capability of having a blog. So I already had PHP, and then from there I created a MySQL server, connected the two together, used Ajax, which is asynchronous Java and XML, in order to be able to query the blog entries from the database and dynamically display them on the screen. And what I ended up with was far more impressive and advanced than what I started with. But I had to start with the simple. And then I incorporated new technologies, new approaches, new capabilities, and it became something distinctive. Today, there are lots of options for a lot of resources and capabilities to be able to hone your skills. Resources that I did not have when I was coming in. So I applied that same passion that I encourage you to in a slightly different way than I'm going to present in a little bit. But just for some background of how I came into the field, when I was in high school, I knew I wanted to get into programming, but the basic programming course was only available to seniors, and it required a few prerequisites, which I couldn't start until my sophomore year. And then by the time my sophomore or junior year, they changed the curriculum because they felt that technology was too important, that should have been part of the freshman classes curriculum, and suddenly everything got re-racked and stacked, and I no longer had an option to take the programming course. But my brother did a few years prior. So rather than being discouraged by this change in curriculum, what I ended up doing is working with my brother a little bit to give me some foundational knowledge, went through the textbooks that he had, and taught myself GW Basic on our home computer. When I was in college, I knew I wanted to get as much experience as I possibly could. So I volunteered to be a lab monitor, which mostly consisted of making sure people weren't doing things that they weren't supposed to on the computer, handing out headsets when people needed it, that sort of thing. But it also gave me my very first experience making Cat5 cables as we transitioned from ThinNet to traditional Ethernet, the Cat5 Ethernet, which today, by the way, we use Cat6, so you probably are more familiar with that term. It looks the same. Also, when I was in college, didn't have a lot of money, but I did find a couple computers that were thrown away in the dumpster when I was taking trash on one time. And I salvaged these systems and I made my own personal home lab out of these systems that were old enough that they were unwanted by their original owners. And they were a bit dated and aged, but they were more than sufficient for my purposes. When trying to learn new technologies I had no familiarity or experience with, such as SQL, I went to the local library and I borrowed books from there in order to learn how this technology works and how to be able to maybe build a server of my own that utilized that technology. Also, in college, I tutored other students in the programming language that I was taking, such as C++ and Java, and that helped my own understanding of the languages as I built examples to demonstrate or as I discussed the topics and concepts with other students. It made me more solid on those same ideas, same concepts. Today, there are a lot more options to learn things. But over my years, I found different ways to make things fun. And that's the secret to making this work, learning new technologies, practicing. That's the secret to being successful, is finding a way to make your projects entertainment for yourself, something that's enjoyable rather than a slog. And when I started, I was really into wanting to make video games. So I made games like Pong. I've always had the idea that Pong teaches you everything that you ever need to know about programming language. If you can make Pong, you can make anything. I remember I made screensavers. Matrix was all the rage at the time, so I made a Matrix style screensaver. I got into hacking ROMs. Eventually learned assembly code for the Atari processor. I'd mentioned the web server that I did previously, so on and so forth. You know, I made some Raspberry Pi projects. Recently, I even got into having a home network attached storage system. Did my first containerization. The point is, all of these little things add up over time. And before you realize it, you have created yourself quite a portfolio that demonstrates your knowledge and experience. And you did it by finding things that you found fun and interesting. And that's what I encourage you to do. So today, there's a lot more options and ways that we can learn new skills in technologies than I had when I was first starting out or a college student. And I encourage learning through the same methods that Bob Ross made famous. Because he's a pop icon, I'm sure everybody is familiar with who Bob Ross is. But I want to make sure you understand the context of where he came from. You know, his show on PBS started in the 1970s. And his passion, the thing that he wanted to do, was make painting accessible to everyone. So the format of his show was to walk through a painting from start to end, comprised in a single episode. In fact, he is the reason why VCRs took off in the 1980s, is because when there were questions about the legality of being able to record somebody else's intellectual property, and in this case, you know, it's the TV and the movie makers that were worried about people recording things and, you know, keeping them from getting the distribution and royalties from that. Bob Ross went to Congress and he talked about the power of being able to record one of his shows and be able to play it back and rewind and pause and play it over again to refresh your memory, so that anyone, regardless of time, could be able to make the paintings like he was demonstrating. Because half an hour is not a lot of time. He could paint that fast, but a newcomer maybe not. We have so many resources like that today, that same capability, through YouTube, through vendor resources, through websites, that you can learn really anything that you want to learn through the internet. So I've provided a few examples, which this presentation slide deck is available on the ISC2 Boulder website. But these few examples, which are accessible links in the download, kind of get your palette wet so that you know like where to start. There's so many more resources above and beyond that I couldn't fit here. But YouTube creators like Low Level are a great resource for really understanding why computers behave the way that they do. He really breaks things down, often down to the binary or the assembly level, so that you can understand why exploits get the results that they do, or why certain code causes errors where you don't think it should. Network Chuck and John Hammond are great resources for learning new products, learning new capabilities, learning new technologies. They have tons of tutorials and things of that nature to give you an introduction to something that maybe you don't previously have experience with. Vendors want you to use their products. They have figured out that the internet is a great way to champion their own resources, their own services, their own softwares. Amazon, for example, they have the Amazon Web Services, like I was talking before. That's one of the cloud environments that's available out there. And they have both videos that you can watch that are tutorials, and they have free actual courses. Now, those are at a specific time, so you register and then you show up online at the specific URL, the location, in order to follow along with their trainings. But it gives you the fundamentals to understand what options and features and capabilities their cloud platform has. When it helps you know, okay, when we're talking about how to create virtual routing, what tool, how to access that. It helps you understand the concept behind like an S3 bucket storage as opposed to, how we normally associate traditional storage, so on and so forth. Splunk is a wonderful tool. It is a product where you can bring in data from all kinds of different places and display it in one unified view and be able to search across different datas and data types and be able to see a normalized version of that data. For example, you could find all logs related to a specific host name, for instance, no matter what format those logs came from. It could be Windows logs, it could be router logs, it could be like VPN logs, so on and so forth. And because it normalizes that data, it knows what a host name is, and you can look for that specific host name and see all of those corresponding logs. They have their own how-to landing page with tons of videos to teach you how to use their product and how to integrate it with other tools. Security Onion is a entire suite of tools. I think it's technically a Linux distribution, but it contains an entire suite of tools to include Elasticstack, which is a competitor for Splunk. It includes Bro, includes a bunch of different tools. And likewise, they have their own website dedicated for teaching how to use their product, which comprises of a bunch of other tools that are open source. Now, there's also websites where you can learn these security concepts and practice them. TryHackMe.com, Hack the Box, and Over the Wire are all great websites that allow you to apply these security specific concepts in a way that won't get you in trouble. Because, in case you didn't already know, you're not actually allowed to hack things. Now, if you have your own personal lab and the traffic doesn't leave your router, then you can go to town on all of your all of your home systems, but not everybody has that capability. And if you, for example, are running things on AWS, you certainly cannot run exploits out there, um, because you have to get approval and coordination through Amazon, so on and so forth. So these tutorial websites, tryhackme.com, Hack the Box, and Over the Wire, are great resources that you can use to learn these security concepts and apply security fundamentals in a validating way. Now this takes me back to the point I've been kind of underscoring this entire time, which is that you really need your own projects. That is where you get your experience. That is where the practice makes um, permanent comes in. That is where learning new technologies comes in. But you have to start with some place to build these things. So there's a lot of options that are out there. If possible, I think that having systems inside your house, your apartment, wherever you're staying, is a great way of going, because it does allow you to have the freedom to be able to do what you want and not have to worry about violating, for example, like I was mentioning, AWS's policies. So you can get systems in order to build your home lab through eBay, through auctions, Facebook Marketplace, places like that, that you can get them relatively inexpensively. Not a lot of people are aware of this, but schools, high schools, universities, the whole works, and I think even hospitals tend to do this, often in order to get some cash to apply to upgrading to newer hardware. They will do auctions of their old systems, and that's some of the best deals that I think that I've seen. Full-fledged servers for $100 or less. It's really impressive. It might be older systems, but most often for a home lab, it is well more than enough that's needed in order to run what you might be trying to run. Once you have a system, don't think that, oh well, I need 5 servers, so does that mean I have to have buy 5 of these systems? That adds up. That's where the great technology of virtualization comes in, and you have VMware Free, you have VirtualBox, KVM. There's tons of options out there for virtualization. And what that allows you to do is you can have one system, and on that system, it can have multiple virtual environments. These virtual systems within the system. So you could spin up a virtual Mac system, you can spin up a DOS system, a Linux system, and you can have all of those virtually talk to each other through virtual networking, and that all exists within that one physical hardware. So that traffic may never even leave that box. So that is a great way of having a home network. Raspberry Pis are also an inexpensive way. You're not likely to be doing virtualization with Raspberry Pis, but they're fairly cheap boxes. You can buy one for, I think, anywhere from $45 to $75. Now the catch there is that they rely on ARM, so it is different technology. It may not work with all software that's out there, but it's an inexpensive way to build a system. For instance, I have a Raspberry Pi that runs Kali Linux, and it can't do things incredibly fast, but it does more than I need for its use case. Now, other options I'd mentioned before, there are cloud services. Azure is Microsoft's cloud environment. AWS is another cloud option out there. Google has its own cloud environment. And I can speak from experience with AWS that you can actually have one or two servers pretty much at all times on AWS, and if you're managing correctly, it won't cost you a penny. Certain capabilities you have to avoid because some features are paid features, but a lot of if you want to build a web server, you can do that for free if you know what you're doing on AWS. Now the catch is you pay for the time that a server is up, so make sure that you spin down servers that you're not actively using, but you can have a virtual lab through these cloud providers. And even when it does cost money, it tends to be fairly inexpensive, which is part of the whole model. And now, once you have systems that you can start putting things on, you are going to need some way to manage configurations, codes, software deployments, things of that nature. I'd mentioned GitHub and Bitbucket before. I highly encourage that you have a GitHub or a Bitbucket in order to have your things published out there for other people to see. It also allows you to iterate off of that as well. You'll need a product like Visual Studio's Code in order to manage your configuration files. That can actually interact directly with GitHub in order to sync things back and forth between GitHub and your local PC, but it also does things like it does color coding based off of syntax, helps you identify syntax errors and things of that nature. And Artifactory is a way to be able to deploy software, configuration files, and things like that automatically, or automagically, as I like to say, to your lab environment. And there's Artifactory and there's Ansible. Both of those are ways to be able to manage your code, your software, your instances. So if you can for example have a configuration in there for your server, and if you make a mistake on your server and it causes a huge issue, you can re-push it from Artifactory and it's like it never happened. And you can do something similar with VMware where you can take snapshots and revert as well. Now, all of this is to set up whatever it is that your project focuses on. If you want to make a web interface, that Nginx, Apache, Go are all programs that provide web front ends. And that's used for everything from not only just having a website, but being able to have services, API communicate together between each other. As I gave the example previously of augmenting a web server with a SQL server, a database, something of that nature, and that's MySQL, Postgres. Those are options that are out there. Maybe you want to have a media server. Well, that's where Plex or Jellyfin, products like that come in. If you're wanting to make containers, Docker and Kubernetes, those are the tools in order to containerize your applications. So you can take your Nginx and make it into a container that runs in a Docker environment, that so on and so forth. Once you have whatever service that you're messing around with, that your project focuses around, then you can take it deeper. You can look at your Wiresharks, and you can use Wireshark in order to look at your network traffic and understand how that communication really works and operates. You can use Nmap in order to see what ports and services are being turned on. You can analyze your database for flaws and vulnerabilities in Burp Suite, SQL Map, You can use Splunk, the product I talked about earlier, in order to parse through all of the related logs and see how these systems are communicating with each other, or even troubleshooting error messages and things of that nature. And I mentioned before Kali Linux, so that's a distribution that's out there that comes with a bunch of security suites, security tools, all of the tools I was just mentioning earlier, but also Metasploit, that you can actually run exploits and compromise systems. And again, do that to your own system. Don't ever leave your network. But that way, you can understand how an exploit actually works. You can watch that traffic on the wire to see what is happening. You can look at the logs that are generated, or configuration changes that occur as a result of that exploit. And all of this is cyclical. It takes you right back to, well, what am I going to do with that? How am I going to iterate on that? How am I going to dive deeper? And you can spin up a new instance, a new service, another like VMware instance, in order to put a new service out there, and just refining your knowledge and understanding on how this stuff works. And if you keep it out on Bitbucket or GitHub, then all of your work is captured and is seen, is able to be seen by prospective employers. And you can show what your capabilities, what your caliber is from work that you have done for fun, that is making you a more knowledgeable, well-rounded individual that has the skills that they're looking for these positions. And keep in mind, all of this is being cyclical. It's eating an elephant one bite at a time. So there are other resources that are available to learn the skills and knowledge that you need when entering the field. ISC2 has an entire webinar series on the website covering how to get into the IT security market, climbing the ladder, interview skills, that sort of thing. So I encourage you to go check out that webinar series. I encourage you to connect with us on our Discord channel. Share ideas for projects that you could work on. Ask questions from those of us in the chapter. The other members of the chapter are also a great resource to learn new information. If there's a resource or a tool that you think should be shared with the rest of the community, we have a Facebook page and a LinkedIn page that you can share that out with the rest of the members. So I hope that you've learned some things today on how not only the skills that you would need when getting into the market, but also how to develop those skills, how to mature them, how to demonstrate your knowledge and experience, how to set yourself up to distinguish yourself from the others that are getting into the field as well. As I mentioned previously, The slide deck and all the links are available on the ISC2 Boulder Chapter website. And I hope to see you again at our next meeting. Take care.